Hello, this is question 6 on your AS specimen or sample paper from Edexcel, the paper 2, and it's the first mechanics question. They say, unless otherwise indicated, you have to use G 9.8 and 3 significant figures, but that doesn't apply to this particular question. Yeah, it's for the rest of the paper. So you have a car moving along a straight horizontal road. At time t0, velocity of the car is u. The car then accelerates with constant acceleration a, t seconds, and the car travels a distance d meters during these t seconds. Yeah, we have this graph. It's a velocity time graph, and they are asking us to find an expression for that distance for d. We know that when we have a velocity time graph, two things are very useful. One is the area under the graph is going to be the distance, and the other is that the gradient of the line is going to be the acceleration. So if we need to find the distance is going to be the area of this trapezium, so the area under the line. We are going to add the parallel sides, so this one plus this one, divide by 2 and multiply by the distance between them. So the only thing that we need to find is this length here, which is the final velocity, yeah, after t seconds. You can find this very quickly if we use the acceleration as a gradient. So if we use the gradient as an acceleration, so I'm going to do that first. So I'm going to find the acceleration is going to be the gradient. So it's the difference in y, which is v minus u. So v minus u divided by difference in x, which is t, which means the final velocity is going to be u plus at. Yeah. So now my final velocity is in terms of the variables that I know. Yeah. So they are giving me u, t, and a. Which means if I go to find the area of the trapezium, because that's going to be the distance, is going to be parallel sides. So u plus v divided by 2, so u plus v divided by 2 times the distance between them, which is t. I don't want to write my formula in terms of v. I don't have v in my formula, so what I'm going to do is to substitute v by what I found before. Yeah, so I'm going to substitute that here, and I have eu plus at. So instead of v, I'm writing that, divided by 2, multiply by t. So I have 2u plus at divided by 2 times by t. I'm going to divide by 2 and then multiply by t in that order. So 2u divided by 2 is u, and at divided by 2 is going to be 1/2 of at, and I'm going to multiply this by t. Expanding the bracket, I have that d is ut plus 1/2 at squared. Yeah, and this is the formula that I need you to find. Remember, when we are finding the SUVAT equations, we can do that with this graph, and the two things that we use are precisely these two. From these two SUVAT equations, because these are two of the SUVAT equations, we can find the other three, eliminating the parameters. Yeah, the a, t. What else are we going to eliminate? A, t, and d. Yeah, and that's all with this question.